Hey, Andrew McLaren here. Today we're going to be going over half reactions, also known as redox reactions. And I want to have you really understand this. So we're going to be looking at this as to how to remember the steps and kind of think about those steps not as just like a list of steps, but how they relate to each other. So we'll go over a simple example just to review the idea of redox. And this will not have hydrogen ions or water, so it's just all about the electrons because that really is what these problems are about. It's about balancing atoms and electrons. And then we'll really try and understand these steps and do a number of example problems as well. Okay. All right, let's get to it. Okay, so when you're doing a simple redox reaction, it might look something like this, where we have something changing into maybe a charged particle, or at least changing its oxidization number. And you're going to oftentimes be asked to identify what's oxidizing and what is reducing, and then to also balance it out. And so when we're saying balance, we're saying that you have to balance out an equal number of atoms, but this is also, you can think about you're balancing out electrons. It's very important that to do the two half steps that we end up balancing out the electrons being gained from one side and electrons being lost by the other. It's the same thing as balancing out our atoms. You can think about it at least in a similar way. So if we look at this reaction, you could do this like the old school method where you've got your fluorine and your chlorine in the center. And this is what we, traditionally teach students at first to do, where you can go through and balance out your atoms in here, and it tells you how many molecules you have up top. And then I think we need two right here and one right there, right? And so that's one way of going through and solving some of these problems. But the problem with a lot of reactions is that they're not easy to do that. This one is super easy to do that. But if you think about the redox reactions, what's going on here is that we've got two little half reactions. You can break this up into what's going on with the reduction. And then you can also say what's going on with oxidization. I need to double check which one's actually getting oxidized and reduced. I could be saying the wrong one. In this case, we've got fluorine, and it is going to be gaining some electrons here. So it looks like we're going to need some electrons here. And if I have one of these, I'm going to need two of these made. It looks like. And then if we have two of these being made, that's -2 charge. So I'm going to need to have two electrons. Okay. So there's two electrons that are being combined with two fluorines, and you get two fluorine ions. And then you can also see right here, we've got the chlorine, and that is, it looks like it has an electron, and we're trying to make a nice neutrally balanced molecule. To do that, we're gonna need to make some electrons here. And so it looks like we need two chlorines. So we need two chlorines, which means there's two electrons. So in this case, it's really easy to add up the two reactions because we have electrons that cancel out. I gave you an easy one to kind of follow. Basically, what you do when you have these half reactions is that you try and play around with getting the charges of the two sides so that they're equal. Like whatever the charge is on the reactant side, the charge needs to be on the product side. So you can kind of see that before we did that part, the charges needed to be equal. Right here. So these were equal charge. And then you were able to cancel out things that appear on both sides of the reaction, because you're essentially saying that, well, if I didn't cancel it out, let's write it out not canceled out. So if we look at this balanced reaction not canceled out, we're saying we've got two electrons plus a fluorine plus two of the chlorine ions. I'm actually gonna just use my hacks here. I don't know why it's trying to do that voice thing. That's not what I need right now. So we got this all being added to that, and that reacts, and we get a two fluorines, it looks like. And then also this stuff right here. So if we were to add the two half reactions together, you could say that this is the reaction, but like with net ionic equations, you don't need to write something that's appearing on the reactants and product side, especially if they're in the same amount. You can just cancel them out. It's like you're using some ingredients and you have some left over at the end. So you can cancel out what was left over with what you had in excess, is another way of thinking about that. So you can cancel them out here. And that should be essentially how we're able to combine these two things. Now, it's really important to keep in mind that the electrons, you shouldn't have any of those left over. Once you're done balancing out your two sides, there should be no electrons left over. That's the main idea here, is that you're combining two different half reactions in a way that cancels out the electrons. So yeah. So let's have a look at a different example of this. If we have like our fluorine or our iron right here, this isn't fluorine, this is iron, and it is reacting to form iron 3 plus. And then don't worry, I'll label what's oxidizing and what's reducing, but maybe I'll get this problem done as well, and then we'll do that. So in this case, we've got, it looks like a neutral charge going to +3 charge, so we're going to need 3 more electrons there. And it looks like here there's a negative charge here, so we're going to need to make this side have some more negative charges. Just like how no matter is being created or destroyed, if that's the case, no protons or electrons have been created or destroyed, so the two sides should have the same charge. That's kind of what's going on there. And so I think we're going to need this to have 2 and then 2 right there. And so in a sense here, what we need to now do is multiply both sides before we can combine them. Because if I were to combine these as is, I'd have some leftover electrons, and we don't want to do that. So we know that there's 3 electrons here. We know that there's 2 there. So we're basically saying I'm going to multiply to cancel out the electrons here. So I need to multiply by 2 and by 3, and that's to to cancel the electrons. And then if we do that, we can rewrite this whole thing multiplied by 2. See, this is why I like using my technology, right? And we can take all of this and multiply that by 3, and we can actually see that these are multiplied out correctly in a little bit. But let's say this is not 3 anymore. So if this is being multiplied by 2, I'm going to just do that with my baby blue just to help us keep track of that. So we got our 2 there. Got, looks like 2 of these as well. And now we've got 6 electrons. And you can think about this now having, we needed to multiply by 3. So we needed to have 2 times 3, which is 6. So we got our 6 here. And then 3 of these, it looks like. And then 6 of these. Okay. And now if we were to combine these together, we should be able to do that pretty easily. And we can also see that the electrons are canceled out. So we can say that we've got this. We also have that in the product side. And I believe we have this as well as one of our reactants, right? So we had iron being combined with this chlorine, and then they have these different charges, and we are happy. So that's the main idea with the balancing out these reactions. You're balancing out through the electrons and trying to make sure that both sides have the same number of atoms and charge. And let's just take a minute to label our reduction and our oxidization. Okay, so I'm gonna label, sorry, I'm getting things are getting a little laggy on me on my program. So oxidization is loss of electrons. So if I look at these two, where was it that we were losing electrons here? So this was like the chlorine had electrons and then they lost them, right? And then the reduction is the gaining of electrons. So gaining electrons, yep, that's gaining those electrons. This gets kind of confusing for some people because, you know, reduction, when you're talking about electrons and you're talking about charge, it's kind of the opposite. So remember when we're saying GER, we're saying gain of electrons is reduction. And so also reduction is like the charge is going down as the electrons go up. It gets a little bit confusing, but if you remember Leo says GER, then that will really help you with which one's which. I swear half of chemistry is just memorizing like what is up and what is down. You know, it's like positive and negative numbers. It's like most of chemistry. So in this case, this is losing the electrons, I believe, right? It's giving off electrons, so that's oxidization. And here, this is reduction because we've got that reduction is gain of electrons is reduction. Yeah, and this is gaining electrons. So you can kind of see how those parts relate, right? So these are the steps that I'm going to go over, but I wanted to help you understand them, and the best way to do that is to not look at them. So we'll go over it soon. But the main things that we need to keep in mind is that this is just like balancing normal reactions, but we need to keep track of electrons and charge. And so we need to balance those out between sides, and we also need, of the reaction like reactants and products, we also need to balance them out between the half reactions, because that's how these things are connected, is through the redox, or that transfer of electrons, right? It's in the name. Redox is all about gaining or losing electrons. That's how we're relating things. Sometimes you're also going to need to keep track of oxidization numbers. So just remember that's essentially like their charge. And so you can think about this like this lead has +2 for its charge, and oxygen has -2 for its charge. Oxygen always has -2. So this is -2 times 2. And so then this is going to have to be +4 to cancel it out. So you can see that this thing, its charge, its oxidization number is going up, right? So its charge is going up. So that's effectively losing electrons. So you can think about if the oxidation number goes up, that's going to cause the charge to also be going up, which means the electrons is going down, right? And then loss of electrons is oxidization, right? So you can think about how these things all relate through that. It's just something that you're going to need to be able to do with a lot of these problems, because they'll ask you to identify what is oxidizing, what is reducing. And you oftentimes need to look at that oxidization number to do that. Something also to keep in mind is that not all of the atoms are given in these reactions when we're trying to balance them, and you have to do process of elimination to figure out what atoms need to be there. So like you can see right here, not only is the charge not balanced, but we have uneven numbers of atoms, right? There's one of these MNs, there's 4 oxygens. And so sure, I could put on an electron here now, but I'm going to need to add oxygens in. And when I add in oxygens, I do that with water, which throws off the charge. And then we're going to have to do electrons later. So how I like to think through this is that there's three main steps that you need to do with kind of like adding into our half reactions before you combine them. And it's these three things. And if you think about this, oftentimes you've got some oxygen, right? And this is related to that oxygen. So that oxygen is oftentimes causing this change. And then when you add in water, you're going to then need to make there be some protons. And so you're going to need to add in some protons to both sides. When you do that, that's kind of affect the charge of both sides. And so then we do the electrons later. Okay, that's the main idea, is that we've got some oxygen, which we need to balance out the atoms. So we add in water, and then to balance out the hydrogen that's added here, we need to add in some protons. To balance out that new charge that's been affected by the protons coming in, then we do the electrons. Okay, so those are like the three main steps, which I had written out over here. There's the first one, which balances out O2, the second one, which is needed to balance out the hydrogen in the water, and then that also is going to then need to happen before we do the electrons, because it's throwing off our charge. So once we have all of our electrons balanced out between the two sides, then it's a matter of combining the two half reactions, and you do that by multiplying both sides by what you need to. Don't look at this as a list of like step 1, 2, 3. Really think through what you're doing, because when you're on the test and you're like, well, what was the first one? What was the second one? What was the third one? You should be asking yourself, why does this one come first and why does this one come last? And you'll find that when you ask those why, if you're able to answer the why, you're able to solve the problem, right? So let's go through an example and show you what this looks like, okay? If we have this reaction, the first thing that I see is that I've got like one thing here, and then I've got another one there. And so those are like my two half reactions. So let's just start off with our Cr2O72 minus, and that's reacting to do Cr3 plus. I think that's chromium. I'm not 100% sure. I'm a little rusty on that stuff. And then our other half reaction is going to be the C2H6O, and that is reacting to form C2H4O. I'm actually going to move this down just to give myself more space and line this up just a little bit better. So if I'm thinking through this, I'm not even going to look at my steps. I'm just going to zoom into this first one. I have the two sides. There's uneven charge. There's also uneven number of atoms. And so the first thing that I should do is take care of the oxygen. And so if I think about this, I need to add in some water. And that water is determined by the number of oxygens. Now there's 7 oxygens here, so I need 7 of these molecules. And each molecule is only 1 oxygen. There's 7 molecules. So that balances out our oxygen for the two sides. Now, I can think about this as adding 14 protons, or 14 hydrogen atoms. So I need to balance out those hydrogen atoms by adding in 14. I'm calling them protons because a hydrogen atom is like a proton and an electron, right? And so we can think of it as a proton or a hydrogen atom. Either name works for that. And so if I'm looking at this, now I've got all of my atoms balanced. I've got all of the oxygen, all of the hydrogens are balanced, but something weird is happening with the charge. And I needed to do this first before doing my electrons because the positive charge on these throws that off. So the electrons is after that. And so if we look at our two sides, I had a charge of 3 plus 3 charge, and I had a charge of, it looks like, plus 14 and minus 2. So this should have, this side has a charge of plus 12. This has plus 3. So I think I need to add in 9 electrons. So we need to make this have quite a bit more negative charge. Actually, hold on. I'm noticing something is not quite right here. My two sides aren't quite balanced. This needs to be 2. Yeah. So you need to make sure all your sides are balanced. Yeah, I balanced out my oxygens, but did I balance out the chromium? No, I did not. So I actually need 2 of these. And so, yeah, this is a good example of slowing down and making sure you really do have both sides balanced. Because if I hadn't seen that, I would have added the wrong electrons, and then I would have multiplied by the wrong number, right? So it looks like I need to have this negative 6 charge, or 6 electrons here. And if we do that, then you can see that you got negative 6 plus 14. I think that's positive 8. And then minus 2, that's 6. Yeah. So now the charge on the two sides is nice and balanced. Okay. So I just kind of was keeping track of charge there and balancing out the two sides, kind of like you would with the atoms, right? So I believe that that half reaction is fully written out. Now we need to do this half reaction. So we've got, in this case, it looks like we have our oxygens are both present on both sides. So we don't need to add in any water. I am just going to write in that we're adding in 0 H2O. You normally don't really write this in, but it's just me trying to show that step. And then we need to add in protons or hydrogen atoms that are missing. It looks like there was 6 here and 4 there. And so it looks like we need to have another 2. And this is going to have that plus 1 charge. Okay. Just kind of double checking everything. I do have the right number of carbons on both sides. Just want to make sure about that. And it looks like because we have those protons here, we're also going to need to have some electrons. This is neutrally charged on this side, and neutral looks like plus 2. So we're also going to need minus 2. So we're going to need to have 2 electrons, because that will cancel out the plus 2 charge. We've got the minus 2 charge there. And so those charges are kind of canceled out there. Okay. So we've got our problem so far. Looks like that. So at this point, we have our 2 half reactions, but we need to combine them. And as you can see, if we were to combine them if we just plugged in and combined everything as it is, we would have a net of minus 4 electrons, because we've got 6 electrons and 2 electrons there. So we'd have 4 on this side. We can't have that. So we have to multiply these two sides by some sort of multiplication factor. And that's going to be what balances out the electrons between the 2 half reactions. Because just like how we need to have mass be conserved between the 2 sides of the reaction in terms of reactants and products, In terms of what's gaining and losing electrons, wherever there are electrons being gained on one half, there should be electrons being lost on the other half of the same amount. So it looks like we've got 6 electrons and 2, so we're just going to multiply this by 1, and this is all going to get multiplied by, what is it, 3? Okay. And then I'm going to rewrite them down below and add those up down below. So I'm going to use my technology because technology is amazing. And so I'm just going to try and do this one at a time. Let's get started with our, well, actually this is written out kind of nice because I don't actually have to multiply everything in this one problem because it's being multiplied by 1. So you'll see more of what it looks like for most of these on this next part. So this half of the reaction did get multiplied by something. It got multiplied by 3. And so it looks like we now have 3 of these, right? 3 times 1 and then 3 times 1. It looks like we have 3 of these. I'm not even going to write the water because you don't really write when you have 0 of something. And then 2 times 3, that was 6 of these. And 2 times 6, there was 6 of these as well. I suppose you could think about, I'm just thinking about the colors, I could make this be the blue numbers just to show that that came from our multiplication of 1, right? You can think about it like that. Okay, so we've got our electrons, those get canceled out. And then we've got some protons. It looks like 14 minus 6, that's going to be, what is that, 8? So there's going to be 8 of these things. So we've got 8, the hydrogen ions, and that's going to be combined with just one of these. I'm realizing I don't need to rewrite it again, right? So we've got one of those, and we got 3 of these. They're being added. And that is reacting to form these guys over here. And it looks like we don't have to cancel out any water here because there wasn't any water on the other half reaction. So that's kind of nice. And then we got 3 of these right here, I believe. And that should be nice and balanced. If we look at our 2 sides of the reaction, we can do like the traditional method here and just double check that we do have the same amount of things on both sides. And it looks like we do have 2 of these. It looks like oxygen, there's quite a bit of oxygen. There's 7 plus another 3 oxygen. And then we've got 7 plus another 3. So both sides have 10 for our oxygen. And then hydrogen, it looks like 6 times 3 is that, what, 18? And then we've got 7 plus, oh, actually, hold on, no, there's the protons as well. So I need to keep that into account. There's that 3 times 6, which is 18, plus another 8 here. Okay. I got concerned for a second there. We got 7 times 2, which should be, I believe, 14, right? Plus 3 times 4, which is 12. That's 26. And this is also 26. So we can see that both sides are balanced with atoms, like the atoms of both sides are truly equal. So this is a nice and balanced reaction. And we can also say that about the subatomic particles, like the electrons on both sides are balanced. Because if you have the same amount of atoms, which are made of protons, neutrons, and electrons, you should have the same number of electrons, right? That's the overall kind of purpose of going through those problems, and that's how you think through them. There is one other way to show this, and that's visually. So you can see this reaction shown visually. And the electrons that we canceled out, like there was 6 electrons that we canceled out from both sides. There were protons on both sides. I think it was 14 and 6. You cancel out the 6, you're left with 8. And then you got 3 of these, just 1 of that. You got 2 of these and 3 of that. And you can kind of see how these things are represented, right? So you have your half reactions. You try and balance out the oxygens by adding in some waters. I think that this might actually be missing my waters. I think I need to add in some waters here. Yeah. And then the waters throw off the number of hydrogen atoms. So you need to add in some protons. Throwing in those protons or hydrogen atoms throws off your charge. So you need to then do the charge after you've done the hydrogen, which you need to do after you've done the oxygen. So just like you think through them like forwards, like I can't, I like to think through it backwards. Like I can't do the charge until I've done stuff with protons, and I can't do stuff with the protons until I've done stuff with water, and I can't really do anything with water until I've like looked at oxygen. You can think through it like backwards as well, right? And so that should be how you think through these problems. Okay, so let's say that we're doing this problem and we're trying to figure out how to do the half reactions. The first thing we need to do is write out what we know as the 2 things that are reacting. We've got fluorine, and it looks like this chlorine oxide thing that's reacting. And the first thing that I see right here is that I can just add on some electrons here, and I need to have my fluorines balanced on both sides. And I believe that if I do that, I've got 2 fluorines on both sides, and I have at that point -2 charge, -2 charge for the 2 sides of that reaction. So just make sure you're double checking your charges are balanced and multiplying out appropriately. And then for this one, I actually, the first time I did this problem, I did the wrong order of steps. And I just kind of want to show you briefly what happens when you do these in the wrong order. Let me just move this down, give us a little bit more room. So what I had done was I was looking at this and I was like, oh, like how I did on the last one, maybe I can add an electron here, right? And that balances out the charge of both sides. But then you also need to balance out your oxygens. And if you do that, then you'll see, oh, wait, hold on. Or this should be red. I should be doing this as green. And this is that green as well, to be consistent with my color coding from the earlier section. So if I add in water, it looks like I need 1 oxygen atom. And to get 1 oxygen atom, we need to add in 2 hydrogens. And to balance out those 2 hydrogens, we end up getting some more protons here, right? And so you're like, okay, well, I need to add in some protons here. Oh, wait, this throws off my charge. So what I had with the electrons earlier, I want to hold off on doing electrons for a little bit. So let's wait on that for a little bit, right? So we'll deal with electrons soon, but let's just do water first. So you can see if you do one of the steps too early, things get confusing. Like if you do electrons too early, it doesn't really work out. And if you're double checking your matter is balanced on both sides, then you'll catch the other ones are missing as well. So if I look here, I have I've added that oxygen in there. I need to account for my protons here. So I think I need to say, okay, I got 2 protons. And then I need to look at the charge here. Charge is neutral on this side. This side is +2. And -1, and so we also need to have another -1 on this side of the reaction, because this had that -1 charge, this has +2 charge, and so we need to actually have electrons on this side of the reaction. And it's a good thing too, because for redox reactions, you need to have the two things be opposite. The one side should be gaining electrons, the other side should be losing electrons, right? So it doesn't really make sense to have the electrons on the right side here because it was on the right side there. So you gotta just use a little bit of intuition, knowing that these are opposites, to double check that that is done correctly. But it looks to me like if we do this, that balances out the two sides. The chlorines are balanced, the oxygens are balanced, the hydrogens are balanced, the charge of both sides is balanced. So that looks pretty good right there for this half reaction and that half reaction. But if we want to combine these, we've got 2 electrons for every one there. So I think we need to multiply by 2 on that bottom one, and then this one's just being multiplied by 1, right? So you can think, oh man, I'm having to move this all over again. This is 2 times that. So we'll rewrite these down below, and I would really encourage you to rewrite these things out below, because the amount of students that I've tutored who just, they get these wrong because they're being lazy, it's painful, man. It's painful for me to even think about. So don't be like that, please. Save us all some pain. Okay, so now this, if we double this up, let's see, gotta move it over here. And again, I'm gonna need to give myself a little bit more space. Okay, so we have that original reaction. It's written as is, and that's fine. I'm just gonna confirm that these numbers are okay as is, and that these now should be multiplied by 2. So now we've got, what's that, 2, and then 4, I believe, and then 2, and then 2, and then I believe that's also a 2. And that's just double check that we did that all correct. Come on, there we go. So 2 electrons, 4 protons, 2 of these molecules, 2 of those molecules, and 2 of that molecule. Okay, it looks to me like we can cancel out our electrons. They're present on both sides. It looks like we also now can just rewrite a lot of this. So we've got that plus another of this. Don't worry, I will get the plus soon. I just want to, you know, get this written, this part out. Okay, so we've got that plus that, and that plus that. So I believe we've got our first reaction there, everything. We've got our second one there as well. Yeah, protons didn't need to be canceled out, and we canceled out everything else that we could. Just water on one side. Okay, so that's one of them. Now let's do another one. Yep, we're doing another one. Let's see, we've got MnO4. And in this half reaction, I feel like I always see this one when they do redox reactions. This half reaction is very common. So if we look at this, I'm going to go through this one a little bit faster than the last one. I can see that there's oxygen, so I need some water. Right, I can see oxygen, water. Okay, I'm going to need 4 of these for every one of those. It looks like these are pretty balanced out. Let's go ahead and do our hydrogens. because now we need to account for that atom. So if we had, what is this, 8 of these, and then let's look at the charge of these two sides. It looks like we've got +2 on one side, and that needs to be equal to +8 -1, and then gonna have to have some other little negative numbers. So this is 7 going to 2, so that's gonna need to be 5, right? And so I think we need to add on 5 more electrons. Oh, but I've ran out of space again. Let's just move this all over there. 5 electrons. And so we've got that is +3, +2. Yep. Okay, so that is good on that charge on that half reaction. Let's go ahead and do our other half reaction. I can see there's oxygen. So the first thing that I need to do is balance out that atom that's not balanced. And it looks like, just making sure that I rewrote everything correctly. I did not. That needs to have a charge on it. Important that you keep track of those charges correctly. So double check that every once in a while. It looks like I did okay on my first half reaction. Okay, it looks like we need some oxygens on this side. So we've got our water, H2O. We need to have 3 of those. And that's going to add some hydrogens onto both sides. So we need to add in some protons or hydrogen atoms. Either or. You can think of them as either or. Okay, so we've got 6 of that balancing out those, right? And then I'm just double checking my work. Okay, that looks pretty good. Oxygens, there's 6 and 6, yep. Okay, so then let's do our electrons and balance out both sides. We've got, it looks like -2 for the charge on that side, -2 +6. So we're also going to need, it looks like -6 for our other charge. So we'll add in 6 more electrons, I believe. Just double checking that again. Yeah, that looks correct to me. Oh man, this is going to be a nasty problem. There's going to be some big multiplications that we're having to do here. I'm just seeing that because if you see here, we've got 6 and 5, and they don't really multiply into each other very well. I think we gotta actually have to multiply this by 5 and that by 6. So, yay. Yeah, big numbers, man. They're not too bad of numbers, but they'll be kind of big. So, I'll do that. And I need to get rid of these numbers. Okay. So originally we had 6 times 5, so that's 30. Got 30 there. And then 6 times 8, what is that? Oh man, is that 48? Yeah, 48. And then this is just 6. Thank you for making that easy. And then 4 times 6 is 24. Numbers are hard, guys. Don't judge me. Especially when you're on a camera live. Not live, but you know, being recorded, trying to do mental math real quick can be surprisingly stressful. Okay, so we've got our 3 times 5, which was 15. You can see why I like these color coding and giving myself some space. And then this is 5. Yeah, I would really encourage you to use these. This is one note that I'm using, but using something like this really helps with doing math. Very, very useful. And we got 5 of these. And then 5 times 6. Oh, that's actually 30. And then so we've got 30 of these. I believe 30 of that as well. Okay. Now we need to cancel out things. I told you the math was not going to be pretty on this one. Okay. We've got 48 minus 30, so that's 18 of these. If you cancel that out, right? 18 of these, and plus 6 of that. And then plus 5 of those. That's reacting to form this. And we also have 6 of these. I don't think we have 24 water, but we've got some water on this side, right? So we've got if we're looking at those two that we added together, because this was being added, right? This is an addition problem. Oh man, that line did not come out straight. Okay, so we've got 18 of those because we subtracted that, minus 30 from both sides. And then we also had 24 minus 15 for this one. And so there's no water on this side, but there is going to be 25 minus 15. What is that? 9? 9 of these water molecules. Okay. And in this final reaction, I believe that that is balanced now. So we could go through this and do the balancing like you did at the beginning of chemistry. You go through your elements and make sure that they are balanced on both sides. And that should help you out a fair amount with that. I actually am realizing, oh man, way late on the problem. I messed this up. Good thing that I'm realizing this. This is how you catch these mistakes, is that things were not balanced on the two sides. I saw that the sulfur was not balanced on the two sides. So let's problem solve on this, okay? So I'm looking back at my problem. I should have done 2 of this. And that's going to change basically everything about this problem. So we're going to have to redo our charges in our every part of that part. Don't worry, we have like most of the problem done, so it'll be easy for us to fix this up. So if we look at this, we have actually the two sides with oxygen now balance out, so we don't need any water there. So oxygen's balanced out. And that means that our protons should also be balanced out. Okay, it's not so bad. And then we just need to balance out the charge. Okay, so we've got -2 times -2, that's -4 for the charge on this side. -4, and this is -2. So we need to add in 2 more electrons. Right, 2 more of these guys. So we had -2. So we need, looks like 2 of these guys. So now we have 2 and 5. Okay, that we can work with. So we are actually going to multiply this by 5, but now this side is going to be multiplied by 2. Okay. So just confirming, yep, that looks pretty good for that first part. But now we need to rewrite these numbers out front here. And combine them. So these numbers are going to be a little bit different than what we had there. But, you know, it's fine. We should be able to get this done still. It'll just take a little bit extra time. Okay, so if we look at 2 times 5 electrons, we have, yeah, let's use the blue. got 10. And then 2 times 8, that's 16. And then the manganese, we've got 2 of them, so there's going to be 2 of these guys, which means there's also 2 of that. And then 2 times 4, that's 8. Okay. And then for the second one, if we're multiplying both sides by 5, there's no water. Don't worry about that. We've got now 10 of those. And then one of these. Okay. Or not, hold on. 10. So this is 5 of these. Yeah. Again, double check that both sides are balanced. Yes, that looks good. Right. And then we actually don't have any of these protons, so that's okay. I kind of deleted that. And then we had 2 times 5, so that's 10 of these. And the electrons cancel out. And we should be left with, actually it looks like we've got 16 of these protons. Because we had 16 and there's nothing going with protons or anything here on this other side, so that's fine. Looks like this needs to be changed to 2. We have 2 of them, right? And then we actually have 10 of these guys, and that will end up forming 5 of those. And not 6 of these, no. Looks like only 2. And then the water, looks like we actually have 8 of those now. Because we had 8 up there. Okay, now let's double check to make sure things actually are balanced between the 2 sides. It looks like we do have 20 of these. That is confirmed correct. It looks like we've got 30 plus, what is that, 8? Yeah, it's 30 plus 8, right? 3 times 10 plus another 8. It looks like we've got, yep, 30, because that's 5 times 6, plus another 8. So that, I'm pretty sure just from that these are good. But it looks like we've got 2 of these, 2 of them there. And then the hydrogen, 16. Okay. And that is 16 on both sides. Yeah, so I would definitely encourage you to double check that everything is balanced at the end, or you could mess up like I did there. But if you do, you should be able to catch your work, but you're only going to be able to do that if you're rewriting this stuff out. Do not use your eraser and just erase this part. I have seen a lot of kids try and do that with these problems. And then if you make a mistake, it's very difficult to go back and change things. It was pretty easy for me because I was using this technology. If you're doing this on paper, make sure you rewrite the whole thing out each time. I know it's a lot of work, but I would rather do the work while I'm working through the problem than have to redo the whole problem from scratch, right? I can just go back and fix a couple things up there as opposed to trying to do the whole thing over again. Okay, that is me going through some practice problems and showing how to fix mistakes. I'll see you around. This has been Andrew McLaren. Thank you for McLearning with me. I've got a few more offers that I'd like to let you know about, and remember, like and subscribe. For each video on YouTube, I am making an interactive version using HP5. These will be for sale on Podia, and if you click on the link in the video, you should be able to go directly to that product. I also have 2 demos I'm going to be linking so you can kind of see what these products look like. So I would recommend checking out those demos. I also offer one-on-one remote tutoring through Wyzant. Please use the links that I have linked below. That way I can get 100% of the hourly rate as opposed to 75. Each video also has a link for my Patreon, and you can join at the $3 level to get some resources I use for tutoring or to support the channel. And I also have a $5 raffle level, which you could either get some free online tutoring or 5 interactive lessons for free. You choose which ones. And then I also have my Teachers Pay Teachers, which has some old lessons that I made from when I used to be a teacher. I may be adding to that. Thank you for spending your time with me. I hope that you learned something.